Good day, everyone. I am Anojan Aha, and I am going to define what a voltmeter is. A voltmeter, also known as voltage meter, is an instrument used for measuring electrical potential difference or the voltage between 2 points in an electric circuit. Its units is volts or V for short. There are analog voltmeters that move a pointer across a scale in proportional to the voltage of the circuit. There are digital voltmeters that give numeric display of voltage. A voltmeter in a circuit diagram is represented by letter V in a circle with two straight lines connected in it. The main principle of voltmeter is that it must be connected in parallel in which we want to measure the voltage. In our sample diagram, we can see that voltmeter is always connected across the component and this is in parallel. Again, how a voltmeter connected in a circuit comes with in parallel across the component. Why is this so? Well, it is because voltmeters are built in such a way that it has a very high value of resistance. According to the construction principle, other types of voltmeters are permanent magnet moving coil or PMMC voltmeters, moving iron or MI voltmeters, electrodynamometer type voltmeters, rectifier type voltmeters, induction type voltmeters, and electrostatic voltmeters. And depending on the type of measurement, we have DC voltmeters and AC voltmeters. And now, let's have Vincent for the parts of voltmeters.
Good day everyone, this is Vincent First of Bisad Sciences 2A, and today I'm going to discuss about the parts and functions of a voltmeter. A voltmeter is used to measure the electrical potential difference between 2 points in an electrical circuit. There are two types of voltmeters, the digital one and the analog one. The analog one has a pointer in it that moves along its scale according to a circuit's voltage, while the digital one provides a more numerical display of the voltage in an electrical circuit. I'm going to show you pictures of a voltmeter. This picture is an analog voltmeter. This is the older versions of a voltmeter, and as you can see, it can only measure 10 volts of electrical potential difference. This is also a more modern version of an analog voltmeter. In this picture, you can see a picture of a connection that is used to utilize a digital voltmeter or a voltmeter. Voltmeter should be connected parallel in a circuit. It is essential because voltage in a parallel circuit experience equal or the same electrical potential difference. And under the connection, there is a photo of a digital voltmeter. As you can see, it is different from that of the analog one. It does not have a scale, rather it has a monitor that shows a more numerical display about or regarding the voltage in a circuit. Hence, it is easier to use than an analog voltmeter. Parts of a voltmeter vary depending on what type of voltmeter it is. An analog voltmeter contains 5 parts, while a digital one contains lesser parts because it has no pointer and a scale on it. But it contains a monitor for display. The first part is the needle pointer. As you can see, there is a metal rod that moves along or hovers across or over the voltmeter's scale. It is connected to a moving coil, and the value it measures depends upon the needle pointer's movement or the place it hovers over along the scale. The next part is the scale. In an analog voltmeter, it is a series of markings or numbers arranged in a semicircle. This is where and how you read the value being measured by a voltmeter. In an analog one, it looks like this. However, in a digital one, it doesn't have a scale nor a needle pointer. It only has a monitor. The third part is the adjustment screw. It is also known as the dial knob or infinity knob. In this voltmeter, we can see the adjustment screw at the side of this voltmeter. Its function is that it allows you to adjust the needle pointer to point 0. It is for you to have a proper and correct reading of the circuit's electrical potential difference. In this picture, you can see the adjustment screw at the center in the part where the scale and the needle pointer is located. In this picture, we cannot see an adjustment screw, but in a digital voltmeter, we can only see buttons for adjustments. The fourth part of a voltmeter are the ports. The ports allow you to connect your test probes into your voltmeter. These are holes in the device where you can plug in your test probes. Sometimes, ports are color-coded, red being the positive port and the black being the negative port. As you can see in this picture, the ports are located at the top of this device. In this picture, you can see the ports. The red port means the positive port and the black port means the negative port. The last part of a voltmeter are the test probes, or also known as the test leads. In this picture, you can see the test leads. Most of the times, the test leads are also color-coded like the ports. Test leads must be connected to the right port. Red test leads must be connected to the positive red test ports, and the black test leads must also be connected to the negative test ports or the black ports. Test leads allow you to connect your voltmeter to a device under test. It fulfills the function of a voltmeter, as the test leads allows you to connect it to a circuit and measure the circuit's electrical potential difference. So there you go. Those are the parts of a voltmeter, and next we have Ivy to discuss about its uses.
When analyzing the operation of an electrical or electronic circuit, or trying to understand why a circuit is not working, eventually you will need to use a voltmeter to measure the various voltage levels. So, as its name implies, a voltmeter is an instrument used in measuring a voltage. That is the potential difference present between 2 points within a circuit. So, to measure a voltage, the voltmeter has to be connected parallel to the component which voltage you wish to measure. And also, voltmeter can be used to measure the voltage drop across a single component or supply. Or they can be used to measure the sum of the voltage drops across 2 or more points or components within a circuit. And now, let us have Joe Maguemo for the difference of voltmeter to other measuring devices.
Good afternoon everyone, my name is Jamo Grama and I will be discussing to you the difference of voltmeter among other multimeters used in measuring electrical systems. Okay, we have voltmeter, ammeter, and ammeter that are all types of a multimeter essential for troubleshooting electrical systems. So earlier, meters were only capable of measuring one unit or one type of electrical value, so a person would have to carry a meter for each unit they needed to measure. Later, meters were designed with a rotary switch so they could measure multiple units of value. So here are the difference of these four. We have voltmeter that measures the voltage or the 2 points of an electrical circuit, and we have ammeters that measures the amps or the current in an electrical circuit, and then we have ohmmeter for ohms that measures the electrical resistance, and then we have the multimeter that measures two or more of these combinations. Apart from that, here are the other characteristics of a voltmeter that gives its difference among other the multimeters. First, voltmeter can measure only potential difference between 2 points in an electrical circuit. Second, to measure resistance of a circuit, an ammeter is also required along with voltmeter. Third, voltmeter is generally not used to test diodes or transistors. Fourth, voltmeter cannot substitute multimeter. Fifth, voltmeter are comparatively cheaper. And sixth, area of application of voltmeter is narrow.
And lastly, let's have RJ Gaschada for the demonstration on how to use a voltmeter.
Hi guys, so today I'm going to demonstrate how to use a voltmeter. Now since we don't have the actual or the standard voltmeter, I will be using a multi-tester to measure the voltages. Now I have here two different types of multimeter, the digital multimeter and the analog multimeter. But today I'm going to be utilizing the digital multimeter because it is more convenient and more accurate compared to the analog one because it renders a reading that is already in numerical form. Unlike with the analog multimeter, it would be a hassle to read between the lines, the fluctuating lines of the parameter. Typically, the digital multimeter comes in a package of two, the test probes and the device itself. Now, connecting the test probes to the digital multimeter device varies on its usage. But today, we're going to only measure simple subjects such as batteries and outlets. First off, we're going to connect the test probes to the device. Now, this black test probes represents the negative terminal and the red test probes represent the positive terminal. Now, we're going to connect the test probe to the port where it says COM or common. And the red test probes should be in the port where it says volt, ohms, and milliamperes. We also need to familiarize ourselves with the symbols on the parameter of the voltmeter. Now this sign right here, V with the straight and dotted lines, it represents the direct current. And on the other hand, this V with the curved or waved line, it represents the alternating current. Having to say that, this portion right here will be used on measuring direct current, while on this part here, it should be used on measuring alternating current. There are also several numbers in the parameter. Now, each of the number is the maximum input of the voltage that the device could measure. Now, let's say we have this battery, this AA battery, which reads 1.5 volts. We're going to be putting the mode on this 2 voltage under the direct current, since the voltage in batteries are indirect current. Now let's try to measure the voltage in this AA battery. As said before, it should be essential to connect the test probes properly on the corresponding terminal of the battery. Now, the red test probes should be connected on the positive terminal of the battery, and the black test probe should be connected on the other end, or the negative side. Now, let's try it. As you can see, the reading already says 1.5 volts, which is correct. As said on the battery, it reads 1.5 volts. Next, we're going to measure this 12 voltage battery. Now we're going to adjust the parameter to 20, since 2 cannot suffice the maximum input of the 12 voltage battery. One of the best features of a digital multimeter is that it has this background light, which you can use to see the readings properly in dimmer places. Like this. Now let's put that to the test. Next up, we're going to measure the typical outlet in our household. Since the outlet produces alternating current, we need to adjust the parameter towards the right in order to switch the mode into alternating current. Now let us switch it to 750, since the expected output of the outlet is 220.